Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called proportions. What is a proportion? Well, let's go ahead and read this along with me. A proportion is an equation that shows two ratios, where they're both written as fractions, that are equal to each other. So it's basically going to be a fraction equal to another fraction. That is what a proportion is, and you can go ahead and underline that or highlight that on your notes. All right. Solving a proportion. To solve a proportion means to find the value of the variable. Same thing as solving an equation. Tips that can be used to solve some proportions. Well, look at the numerators and the denominators. There may be a shortcut using multiplication or division, and you'll see what I mean here if you look at these two examples. Now, 1 and 2 are 100% typed up for you, but I want you to go ahead and follow along with me here on my screen. We got 3 over 8 equals h over 40. Is there a way that 8 could be made to become 40? Well, if you know your multiples of 8, you would know 8 times 5 would give you 40, so then simply multiply the 3 times 5 as well. And that will transform this first fraction of 3/8 into 15/40ths, because 3 times 5 is 15. And if they're both having the same denominator, then we can conclude that h would equal the 15. Once the denominators are equal, we can conclude the numerators are also equal. The reason we were allowed to do this is because 5 over 5 is the same as 1, which is why we could multiply the 8 times 5 and the 3 times 5. Now, the shortcut. When you see that you have a denominator that can be multiplied by something to get the other denominator, then you're going to take the numerator times that number as well to get the answer for the variable. Take a look at problem number 2. This one's a little bit different. This one has a variable in the denominator. So look at the numerators. Could 60 become 10? Well, yes. If you take 60 and divide it by 6, then that would give you 10. So we're going to take 84 and divide it by 6 as well. 60 divided by 6 is 10. Obviously, now both numerators are the same. 84 divided by 6 is 14. Once the numerators are equal, we can conclude the denominators would also have to be equal, and therefore W is equal to 14. So shortcut again. You could divide sometimes for shortcuts. To get from here to here, we divide by 6. So we take 84 divided by 6 to get the answer for W. All right. Are all proportions that easy? Do they all have shortcuts like we saw in 1 and 2? The answer is no. For example, 8 over 15 equals V over 28. Does this one have a shortcut? Could 15 be multiplied by some nice whole number to give us 28? No. So, good news, there is another way to solve proportions, ones that are not as easy and quick as 1 and 2. It's called the cross products rule. If two fractions are equal, and you can see these two fractions are definitely equal, we have an equal sign in between, then their cross products are also equal. What does cross products mean? It means cross multiplying. So go ahead and draw this on the right side of the page. We're going to take 28, boom, draw an arrow. We're going to multiply it to 8. And we're going to take 15, boom, draw an arrow. We're going to multiply it to V. And we're going to keep the equal sign in between. So again, we're taking the 28 times 8. We'll do that over here. 15 times V. We'll do that over there. What is 8 times 28? Feel free to use a calculator. You will get 224. Write that down underneath. Bring down the equal sign. 15 times V is just 15V. To solve for V, we ask in our head what's happening to the variable. It's being multiplied. That's what it is. Whenever you have a number right next to a variable, that's multiplication. So to get that variable by itself, we will have to divide by that 15. And that will give us 14.93 repeating in your calculator. You would take 224 divided by 15. You will notice that 3 continues to go on forever. So we put a repeating bar over it to get our answer, 14.93 repeating. Now, the reason I'm even teaching you this lesson is because proportions can be used to solve many real-life scenarios that deal with proportional relationships. It's another way of solving them compared to what we've already learned for writing an equation for proportional relationships on a previous packet of guided notes. So here's the big idea. Another word for equal is same. That's really big here. Equal means same. So, therefore, when two fractions equal each other, their units of measure and what their values represent must be the same. You're like, Underkoffler, what do you mean? I'm talking about the numerators, they have to be the same things, and the denominators have to be the same type of things, specifically when we're talking about the units of measure and what their values represent. Take a look at problem number 4. A room with an area of 156 square feet, that's what that little 2 means, square feet, takes a carpet installer 45 minutes to finish. How long will it take to install carpet in a 108 square foot room? Which is the correct proportion? Well, we need them to be set up the same way because since there's an equal sign in between, they have to be the same. So we need the units of measure in the numerators to be the same. Oh, this first one, square feet in the numerator, square feet in the numerator. That's the same. How about the denominators? Minutes in the denominator, X minutes in the denominator. That's the same. Ding, 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 ding. Go ahead and circle that on your page. That one has the units of measure at the same places. Square feet, both on top. Minutes and minutes, both on bottom. The problem with the one over here on the right is that it flip-flopped the second fraction and put minutes on top and square feet on bottom, which was not the way that it was done on the first fraction. To set up a proportion correctly, both fractions have to be set up the same way. In fact, turn the page. Let's look at another one together. Problem number 5. Joey has traveled 244 miles in 4 hours. If he drives at the same rate, how long will it take him to drive 91.5 more miles? Okay, let's put an equal sign and let's set up our fractions. The easiest way to set up your fractions is to pick the first ratio that the problem talks about and write that as your first fraction. So that's exactly what I'm going to do. I'm going to write 244 miles over 4 hours. Hopefully you're writing this down as I'm showing this to you. Yes, I would put the units of measures in the fractions if they are different, and clearly here they are different, miles and hours. I need you right now to quickly hit pause and see if you can figure out how the second fraction should be set up. We have how long will it take him? That's an unknown. We could call that X hours. And we have 91.5 miles. So where's the 91.5 going to go? Where's the X going to go? Hit pause, figure that out right now, and then hit play to see if you got it correct. All right, did you already set up your second fraction? Since we had miles on top in the first fraction, we should put miles on top in the second fraction. And yes, a half is the same as 0.5. That's probably the quicker way of eventually doing it in your calculator. Since there's 4 hours in the denominator here, how long will it take him is X hours, and that will go in the denominator just like we had hours in the denominator over here. Miles over hours equals miles over hours. Now, if you wanted to be creative and do hours over miles, even though that's not the way that would work well for a unit rate, we're not really doing unit rate here on this packet of guided notes. So you can actually do this as long as both fractions are set up the same way. If you want to do hours over miles, you can do hours over miles. And here's the cool thing. When you cross multiply, you're going to take 244 times X. Well, when I cross multiply, I'm also going to take X times 244. Over here, you're going to take 4 times 91.5. Well, I'm also going to take 4 times 91.5. So this proves both ways will work. You just have to be consistent. Both fractions must be set up the same way. All right, calculator time. X times 244. Well, we don't need a calculator for that. That's just 244x. Put your equal sign. What's 4 times 91.5? Use your calculator, 366. All right, inverse of multiplication is division. So whatever number is multiplied to your x, divide by that number on both sides. That's how you solve a proportion at the end. Go ahead and in your calculator, take 366 divided by 244. Boom. You should get 1.5 or 1.5. And we will put the unit of measure here on our answers to solve this real life scenario problem, 1.5 hours. All right, now that I have led you through problem number 5, I would love for you to try number 6 on your own. And if you're not 100% feeling super confident, at least try to set up both fractions. If you don't want to solve until after you hit play to see how you did, that's fine. Hit pause, at least set up the two fractions with the equal sign in between, which is called a proportion. If you want to go ahead and solve, you may, and then hit play when you're ready to see how you did. All right, did you already set up number 6? Let's see how you did. 35 minutes, 160 people, I'll make that my fraction, equals how long would 220 people have to wait in line? Well, I put my people in the denominator here, so I better put my people in the denominator here as well. Minutes on top, minutes on top. Now, maybe you did it the other way. Maybe you put the people on top and the minutes on bottom. Then you better do that for the second fraction as well. Both ways will work. All right, to solve, we are going to go ahead and cross multiply. Calculator time, 220 times 35 is 7,700. And I don't really care which side you put that number on. You might have put it on the other side, especially if you had to set it up this way. Honestly, won't matter in the end. 160 times x is 160x. We will divide by whatever number is multiplied to our x to get that x by itself. And we get a final answer of 48.125 minutes. Now, that's kind of a weird answer, 0.125 minutes. In your calculator, if you ignore the 48 and just hit 0.125 and multiply that times 60, because there's 60 minutes in every hour, as we know, then that, and there's also 60 seconds in every minute, is what we're really talking about here. That's going to go ahead and give you the 7.5 seconds. So that way kind of sounds a little bit more logical, 48 minutes, 7.5 seconds. I will honestly accept it either way, but there you go for problem number 6. All right, let's switch it up a bit. What do we do when all the units of measure are the same? Some problems are going to present a scenario where everything is described in the same unit of measure. In that situation, we need to decide how we're going to set up our fractions. The way we set them up will be based on what each measurement represents. Now, if you don't really know what I'm talking about, you'll see what I mean when we look at number 7 together. A 3-inch by 5-inch photo is enlarged so that the length of the new photo is 9 inches. Find the width of the new photo. All right, did you notice everything was in inches? Well, then we got to use something else to set up our fractions. Did you catch that they talked about length and they talked about width? Those are two slightly different ideas. Normally, we think of the length as the longer measurement and the width as the shorter one. So, using that mentality, here's a hint. When they said 3-inch by 5-inch, 3 inches would be the shorter measurement, so that's your width. And the length is the longer measurement, so that is your 5 inches. And what I can do then is I can decide to set up all of my fractions, well, both of my fractions, as width over length. Go ahead and write that down on your paper. Width over length. So, what was the width? 3 inches, and the length was 5 inches for the original photo. Equals, well, I got to set up the second fraction the same way. The length was 9 inches. Length is in my denominator. So find the width. So the width is unknown. You can call that X. I'm going to go ahead and call it W because I like that for width. Doesn't really matter. You might have noticed, Mr. Underkoffler, what are you doing? You're not putting units of measure in your fractions like you did for numbers 5 and 6 above. Well, that's because all the units of measure are the same on this problem. So when they're all the same, you don't really need to write them down for your proportion to set it up. All right, from here we can cross multiply. 9 times 3 is 27. 5 times W, boom, is 5W. Divide by 5, calculator time. 27 divided by 5 gives you 5.4 inches equals W. Now, I did put the unit of measure on my final answer. It's good habits to get into. All right, why don't you try one on your own? Try number 8, hit pause now, and then hit play when you're ready to see how you did. Did you already try problem number 8? If not, you'd better try it, at least set it up to make sure you're trying some of this on your own. All right, here we go. So we are talking about pages that is being read in books, and we got two different people. We got Sam and we got May. So, how are we going to set this up? Well, it's your choice. I'm going to do Sam's pages in the numerator, May's pages in the denominator. That would make it 8 over 11 from the very first sentence. Sam read 8, May reads 11. But now they're saying Sam reads 28. Sam's number is in my numerator, so May's unknown number is going to be in my denominator. Cross multiply, you'll get 8m for 8 times m. 11 times 28 is 308. If I'm going too fast because you didn't have this right already, feel free to hit pause if you need to fix your errors. From here, we divide by 8 on both sides, and that's going to give us the answer of 38.5 pages. Oh, by the way, I should have mentioned this, and I don't have this typed up on my screen, but you could do May in the numerator and Sam in the denominator as long as you do it on both fractions. So instead of 8 over 11 and 28 over m, it would have been 11 over 8 and m over 28, and that would have still worked out the exact same way. Make sure you put the label on your final answer. Okay, let's talk about ratios. We've already been doing ratios when we've been setting up these things as fractions. Well, let's talk about how we can find the total when we need to do that. So far, we haven't needed to know total pages. Like on the last problem, May and Sam, we never had to talk about how if it's 8 and 11, that's a total of 19. Never had to do that, but there might be some problems coming up where you might need to. So here's an example. Let's say the ratio of cats to dogs is 9 to 5. Sometimes you're going to see a little colon in there. It's just like saying 2, 9, 2, 5. What is each number out of? Well, it's simple. If the ratio is 9 to 5, for every 9 cats, there's 5 dogs, that's a total of, well, add them up, 14. So the ratio's total is 14 from that 9 to 5 ratio of cats to dogs. What does that really mean? That means, remember how there were 9 cats? In fact, I should probably go ahead and highlight this. The first number responds to the, correlates to the first word from the ratio, and the second word from the ratio, dogs, is the second number. So down here, we are talking about 9 cats out of 14 total animals. And I think this is already typed up for you. My apologies for not already saying that. And then for dogs, we know that there were 5 dogs. We talked about that up here out of, again, 14 total animals. All right, why don't you try one here on your own? Hit pause now, fill in all of these blanks, very similar to the last problem that we did. Then hit play when you're ready to see how you did. All right, did you already try this one on the bottom right-hand corner of your page? Here we go. Let's see how you did. Student to faculty ratio, 25 to 2. What is each number out of? Well, they're out of 27. That is the ratio's total because we just add them up. All right, now, did you catch who was first? Student is first. So 25 is student, faculty is second, so the 2 is the faculty number. So there are, boom, 25 students is what we had here from the ratio. Out of a total of 27 people, there were 2 faculty members out of a total of 27 people. Now, again, you might be like, Underkoffler, why in the world are we doing that? Turn to the next page. You'll see what I mean. Problem number 9. Follow along with me as I read it out loud. The ratio of adults to kids at a concert is 19 to 11. But the next sentence says, and you can go ahead and underline this. Let me switch to my pen. If there's a total of 420 adults and kids, that means the 2 together as a grand total at a concert, how many of them are kids? So you see how this problem's a little bit different than what we had for numbers 5, 6, 7, and 8. They never really talked about taking the 2 categories and making them a grand total, but this one does. So let's make sure we know what the total was from the original ratio. 19 and 11 for that ratio gives us a total of 30. Now, what does the problem want us to find? I'm going to go ahead and highlight this. It wants me to find out how many from the concert are kids. The ratio of adults to kids. Kids was the second part. That's the 11. The adults is the first part. That's the 19. How am I going to set up my fractions? Well, I have a total number, and I'm trying to find how many are kids. So I want to, and I recommend you write this down. We definitely know we need total, but we need to talk about the kids, not the adults. So watch how I do this. 11 was the kids from the ratio, and that was out of the ratio's total of 30 total people. I'm going to set that equal to, what was my new total? 420. How many are kids? I don't know. I'm going to go ahead and call it X kids. Kids over total equals kids over total. Notice I'm not using the adults because the problem did not ask me to find how many were adults. All right, from here, let's go ahead, get out our calculators. Let's cross multiply. We know 30 times X is 30X. 420 times 11, go ahead and do that in your calculator. You should get 4,620. Whatever numbers multiply to X, we're going to divide by that on both sides. And that is going to give me an answer of 154 kids. Now, I want to take you back to the shortcuts we talked about on the very first page. I don't know if you realize this or not, but forgive me as I try to move this out of the way. 30 can make 420. Maybe you didn't know that, but yeah, 3 times 14 is 42, so 30 times 14 is 420. So there was a quicker way of solving this. I could have just taken 11 times 14 and boom, I would have gotten 154 without having to cross multiply and later divide. Now, you might be like Mr. Underkoffler, well, what if I don't notice there's a shortcut? Okay, not the end of the world. You'll cross multiply and later divide. You'll still get the right answer. But whenever you can discover shortcuts, like I did here with the 30 and the 420, don't forget those shortcuts. Once you recognize them, can make it solving this a lot quicker. All right, I want you to try the remaining of these problems on your own. And they're not all going to be total type of problems like number 9. Spoiler alert, number 10 is. You might have already started reading it. Notice it said total right here. But when you get to 11, 12, 13, 14, they're not all the same as 9 and 10. Maybe one of them or two of them are. Maybe some of them are similar to problems like 7 and 8 from the previous page where all the units of measure are the same. So I'm kind of giving you a variety of problem solving here on this last page of guided notes. So time to hit pause. Do all the remaining problems on your own, then hit play when you are ready to see how you did. All right. I hope you're ready. I hope you already did 10, 11, 12, 13, and 14 on your own. Here we go. This problem does talk about a total of 150 televisions. So what was the ratios total? 9 plus 16 makes 25. But they're asking how many are 4K. So I only need 4K's number from the original ratio and the total. 4K's number was 9 because it was 4K to HD TV. 4K was first, so that's 9. 25 is the total. Set it equal to unknown X 4K out of a total of 150. You can cross multiply and solve, and that will give you your answer of 54 4K TVs, or you could notice the shortcut. Since I can take 25 times 6 to get 150, think quarters, then I can take 9 times 6, and that will give me 54 for my answer a lot quicker if you know those shortcuts. Problem number 11. This is not a total problem. We got veggie plants, we got fruit plants. So if you're going to do 30 veggie over 12 fruit, then you're going to have to set it equal to 20 veggie over X fruit for how many fruit plants. Could you do it the other way? Yes. As long as you set up both fractions the same way, either setup will work. Cross multiply and solve, you are going to get 8 fruit plants. Yes, there was a shortcut to this. Although it might not have been as obvious, 30 times 2/3 makes 20. So 12 times 2/3 would have made 8 fruit plants. That could have been a possible shortcut for solving this problem. Problem number 12. Oh, we are talking about ding, 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 total, just like number 9 and number 10. So did you find the ratios total? 11 plus 5 giving you 16. They're asking how many long sleeve shirts are in his closet. So we need long sleeve shirts and we need total. The long sleeve was the second part of the ratio, so that is the 5. 5 out of the total of 16 equal to unknown long sleeve out of a total of 48. Oh, you might have noticed the shortcut here. 16 times 3 makes 48, so you can take 5 times 3 and get your answer of 15 very quickly. If you didn't notice that shortcut, you cross-multiplied, later divided by 16, and got the exact same answer. I do not care which way you decided to solve it. Although shortcuts are pretty cool. Problem number 13. We are talking about earnings money and savings accounts money. Yes, it's all money, so you can't just say the numerator is always going to be money and the denominator is always going to be something else. They're all money. So I decided to set this up as earnings over savings because that was the order in the opening sentence. So that would make it $40 of earnings, $24 of savings, equal to unknown. I called it E for earnings out of $510, not out of, but for $510 of savings. If you want to do it the other way, that would also work. Cross multiply and divide, you're going to get a final answer of $150 earned. And finally, problem number 4. We are talking about 3-pointers made and those that are attempted. So we had 56 made, 160 attempted equals 77 made. That's right. How many will she need to attempt to make 77 3-pointers? So that's 77 that she's going to make out of, we don't know how many she would need to attempt. Yes, you could do it the other way, although probably most of you put the attempts in the denominator because that's kind of like what they're out of. Cross multiply and solve, and your final answer is 220 attempts. All right, thanks for watching this video. We'll see you next time.